Learn it in a burst, yeah, write it future words.
Hi students, I'm your lecturer Mr. Fun Man for CM3261 Environmental Chemistry. Today we are going to talk about the topic element cycles, and it's my pleasure to introduce to you Shaphyna, who's going to bring you through this topic.
Hey guys, I'm Shaphyna, and I'll be going through this lecture with you on element cycles. This lecture is divided up into 6 parts: the biogeochemical cycles, the water cycle, the carbon cycle, the nitrogen cycle, the phosphorus cycle, and nutrient enrichment. Let's dive into the first part of the biogeochemical cycles. Nutrients move through ecosystems in nutrient cycles, also known as biogeochemical cycles. Chemicals, elements, and molecules travel through the atmosphere, hydrosphere, and lithosphere, and from one organism to another in a dynamic equilibrium. Physical matter of an ecosystem is circulated over and over again. Nutrients and other materials move from one pool or reservoir to another, remaining for varying amounts of time in each, also known as its residence time. The rate which materials move between reservoirs is termed as flux, and flux between any given reservoirs can change over time. A reservoir that releases more materials than it accepts is called a source, and a reservoir that accepts more materials than it releases is called a sink. Now let's take a look at a real-life example of Chesapeake Bay in the early 2000s. The native eastern oyster, Crassotria virginica populations had dropped by 99% in Chesapeake Bay in 2001. The Chesapeake's oyster industry, one of the largest in the world, had collapsed. This was due to a multitude of reasons, including poor water quality, reef destruction, virulent diseases spread by transplanted oysters, and 200 years of overharvesting. This ultimately led to the destruction of oyster reefs. Since oysters settle and grow best on reefs, artificial reefs were then constructed to get oysters off the bottom of the sea, away from smothering sediments and hypoxic waters. This was an effort to push them up into the plankton-rich upper waters to allow them to grow and thrive better. After a few years of implementation, the oyster populations on the constructed reefs were sampled in 2007. The reef complex supported about 185 million oysters compared to the wild population of 200 million oysters living in the remaining degraded habitat in all of Maryland, showing the success of the artificial reefs. Next, let's move on to how human activity can affect fluxes. Human activity has increased the flux of nitrogen from the atmosphere to the reservoirs on Earth. On the other hand, it has also increased the flux of carbon from the reservoirs on Earth to our atmosphere in the form of carbon dioxide. Biogeochemical cycles involve negative feedback loops that promote dynamic equilibrium. However, some human actions can generate destabilizing positive feedback loops on various element cycles. And that brings us to the end of the first part of biogeochemical cycles.